So I'm recording. All right. Greetings, everyone. Thank you for joining us at Exchanging Ideas 37 Global 5G Evolution. To the speakers, thank you for joining us wherever you are around the globe. I really appreciate and so grateful to all of you to make this event happen. At the end of today's session, we'll have a 10 minutes Q&A, and I would like to propose one question to all the speakers. And the topic of the question is how 5G can solve indoor coverage challenges. And the 5G technology has the potential to address indoor coverage challenges in several ways. One of those is the higher frequencies in terms of how we can utilize the millimeter wave. Second is the small cell deployment. Third is the beam forming technology. And just one second, trying to move the slide. I'm having issue in moving the slide. Okay, so now the second is the massive MIMO, and the next is network densification, and 6 is hybrid solutions. So these are the areas that we can able to solve in terms of the interference, cost, and infrastructure deployment, backhaul connectivity. But however, I would like to love to hear from the speakers based on your experience, based on your customers, based on what you have seen in reality, in the real life about the indoor coverage challenges. Because in Malaysia, for example, our service provider or network infrastructure provider have successfully deployed it for the outdoor, and it works very well for the outdoor coverage. But unfortunately, the indoor coverage still have some major issues. It can be technical or it can be a non-technical. But this is not a country-specific issue, but it is an international issues. It is a technology, or it can be non-technical issues that any other mobile operators are also equally facing. So we would love to hear those during the Q&A session as well. And I'm Kaneshwaran Goindasamy. Thank you for joining us today. And just one second. And I would like to present the presentation of the future is bright. Just one second. I'm trying to see if it's on still in the recording position. Yes, it is in the recording position. All right. So what I would like to present is the mobile network operator 5G standalone enhanced mobile broadband network commercially deployed. And in this case, we would like to express the currently there's a 43 live standalone networks for enhanced mobile broadband. And in Q1 2023, there were 4 mobile network operators have launched the 5G standalone networks. The FWA or private 5G are not factored in this case. Telefonica Spain is coming in pipeline as well. The Deloitte Global says it expects at least 200 by the end of this year of trials, test plans, and deployed as well. This is the numbers by Ericsson. If you see in the purple color, the monthly mobile data traffic per sub for South Korea, there's average about 27 GB data. A lot of developed countries with 5G deployment are in the range of 10 GB up to 20 plus GB per month. In South Korea itself, 78% of traffic on 5G network is being deployed, one of the top dominant in the world. If you see in the bottom is the figures of Ericsson's deployment, and it's very interesting to see that, fixed wireless access is getting a very strong traction. There's a 9 million radios that has been shipped as well by Ericsson. Now, if we look at the 5G enterprise market size, expected to reach about USD 10.9 billion by 2027 at a CAGR of 31.8% during the forecast period, right? So it is very clear that there's a huge potential opportunities for the enterprise market. In terms of the market dynamics, major factors that are driving the growth of this market is the emergence of Industry 4.0, paving the way for the massive machine type communications. Number two, the development of the smart infrastructure. And number three, the delivery of differentiated 5G services using the network slicing. Network slicing, it is so critical, so important for the mobile network operators because majority of their customers are the enterprise market, at least 70 to 90%. And this network slicing will be much more appropriate with the various of new innovation of business models. Nevertheless, convergence of Wi-Fi 6 and 5G also plays a key role because of the strength of the use cases of 5G can complement as well together with the Wi-Fi 6 use cases. Now, the future is bright for 5G in the enterprise based on the source of 5G America. We can able to see on the top is the cellular network of the enterprise connectivity and the narrowband IoT connectivity as well. But when it comes to non-cellular networks, the lower powered WAN, LoRaWAN, the machine-to-machine IoT, remote connectivity are also play an important role. So enterprise can enjoy the cellular and the non-cellular, wireline, wireless as well, and not leaving the private cellular networks as well, because that is getting more popular market penetration as well, right? Now, when we look at 4 mega trends for 5G millimeter wave in 2023 and beyond, industrial use cases are very closely associated with millimeter wave in the range of 24 to 40 gigahertz, very relevant to indoors. However, lack of millimeter wave supporting devices preventing the market from fully evaluating the effectiveness of the millimeter wave performance, right? So some of the main use cases are AR, VR, XR that brings a new focus for the indoor applications. Smart repeater innovations also can be playing a good role in terms of street light mounted smart repeaters, and also the 5G fixed wireless access that can be relevant to the millimeter wave as well. So in order to enable the high quality of connectivity, there must be a clean, dedicated spectrum for a use case can provide interference protection from the third-party systems, and also improve data flow, buffering, and quality discipline between the applications and the network layers as well. Now, when we look at the enterprise market, another area of Ericsson is the communications and network APIs. Vonage can today boast a community of about 1 million developers. Ericsson's acquisition of Vonage is a big idea to position Vonage and its platform as a kind of broker between the developer community and the telcos as well, right? So this is another new trend of the API platform. Camara is an open source project within the Linux Foundation that is able to define the develop and test the APIs. Camara works in close collaboration with GSMA operator platform to align the API requirements and publish the API definitions as well. So network APIs to service the API is necessary to simplify the telco complexity in making APIs easy to consume for customers as well. And it's good to facilitate application to the network integrators as well. Ericsson's strategy very much focused into the enterprise communication platform, accelerate the world's ability to connect global network platform as well. Monetize differentiated 5G connectivity is quite important as well. Based on the Ericsson, how to monetize differentiated 5G connectivity, after reviewing about 2,880 subscription plans for 205 telecom operators globally, quarter one 2023. it is clearly identified the entertainment category from the CSPs and the OTT players is gaining so much of traction. Typically, the video streaming services and the most popular for the 5G plans, entertainment, music communications, social platforms, security, banking, these are the most preferred when it comes to the enterprise. Requirements for wearables, we know that wearables, industrial wireless sensors, video surveillance are getting much more traction when it comes to the enterprise market. And lastly, I would like to stress here is that most recently T-Mobile came out with this since 2012, they had worked with the accelerator program that nearly 100 different startups, developers, and innovators support and introduce emerging technologies that transform the way the consumers live and business operate. And out of that, today, they have actually chosen 9 developers in the XR, AR, VR, in sports and entertainment as well, right? And this is quite interesting. One of them was that a stadium filled with 5G enabled drones capturing never before seen what athletes are seeing in the real time AR, VR experience of 5G connected robots delivering concessions throughout the venue as well. So this is overall the traction or the trends among the enterprise market. And this is overall of my presentation. Thank you so much. And I would like to pass on to the next speaker. I would like to introduce Rajesh Radhakrishnan from Mumbai, India, to present on the 5G indoor planning best practices. Over to you, Rajesh.
Thank you, Ganesh. So let me share my screen. Yeah. Yeah, thank you very much. Thank you very much for inviting us for this and giving a space in this platform. And we are very happy to share our experience and software capabilities. So iBwave is a company which was based in Canada, and now we are the part of Corning Optical Communication Division. And 20 plus years we already completed, and we have the softwares for wireless and wireline indoor and outdoor design, survey design applications, and almost more than 1,150 customers globally in 100 countries. And we trained and certified more than 3,350 people. They become professionals for in building wireless radio planning. And we have a superb customer support team, and we support our customers 24/7. And our team speaks 15 different languages. And we have a team especially in India also. And our customer support rating is 93%. So this is a snapshot of the customers who trusted us for making their indoor and outdoor wireless and wireline designs. You can see the major telecom operators in this region, as well as the global players also, and the enterprise OEMs, system integrators. So we are there everywhere with all type of telecom enterprise and operator teams. So as I said, we have a different kind of software solution. Especially, we have one indoor planning solution. We call it as iBwave Design Enterprise. This supports all the technologies, including 3G, 4G, 5G in LTE, Wi-Fi, IoT, public safety, and etc. The same way, as a desktop planning, we also have a field level preliminary planning and designing software. It's an Android mobile based one. We call it as iBwave Mobile Survey and Planner. And we have another equipment. It's called Equip Prism Solutions that will specially for the public safety. The same way we have special software solutions for private network, LTE and 5G and Wi-Fi. Then we have a fiber planning tool that is an FTTH campus planning tool. We have public safety planning tool, that is critical network for the airports and seaports and etc. And we have a collaborate management and collaboration platform. It's called iBwave Unity. So that will talk in between all the softwares and give you more site management reports, project management reports, and etc. So here I would like to talk about the design practices. So the first one is control everything completely. So this is a workflow. This is proven and it is implemented and people are using in India for 4G as well as 5G now. So digitize your complete workflow, which start from the survey, design, optimization, deployment, and post-implementation validation. So, and use one tool for the complete survey of a Wi-Fi, CBRS, LTE, and 5G. So one person equipped with one tool, if we can do every survey, so that will save a lot of time. And this workflow will accelerate your 5G deployment. That save your time and money. Then for a 5G, especially we talk about in building, the building modeling is super important. The reason, the building material characteristic, especially for 5G, we operate with two different frequency bands in India and subcontinent, millimeter wave and sub-6. So the characteristic, the reflections, refraction, diffraction will change, depends on the frequency and depends on the type of the material. So the 3D modeling is super important. And the next one is the prediction algorithm. So iBwave have a proven prediction algorithm. It's called fast ray tracing. So that will give our customers a accurate and optimistic prediction results. Then we have a capability for configuring the systems, that is the small cell or G node B antennas and all the DAS components. So the software have a capability to configure and create that model. I will go in detail in next slide. Then streamline indoor and outdoor designs for campus environment. If we make any campus environment for 5G, we need to make sure how the macro network is impacting to the indoor wireless network. So iBwave have a software suite for that, iBwave Reach and iBwave Design, that will, both the software will collaborate and will give us a optimistic design. This is few model of our 3D modeling capabilities. We can make any type of building. We need any input in 2D drawing, in image or PDF, AutoCAD. In one click, iBwave will make that into 3D. So hospitality, any stadium, tunnels, and the residential building also, any type of building. There is no limitation in the type of building. All type of building we can create a advanced 3D predictive modeling. Another one, the system configuration and equipment modeling. So as Ganesh said, the beam forming and the beam configuration, this is super important for a 5G design. So iBwave have that capability to create a beam forming component by using its specification sheet. So we call it as VEX files. So they can create the database component by using iBwave tool, and they can use that for their indoor wireless design. Once they have created a multi-beam antenna as an example, they can run the prediction based on the beams, and they can play with the beams, changing the beams to get more and more good SINAR results. The same way they can do the configuration in their small cell or the G node B in terms of numerology, bandwidth partitioning, and slot formats, and network optimization and configuration parameters of 5G NR also. The another important thing is macro. So this is a use case where iBwave outdoor planning tool, that is iBwave Reach, they created multiple macros and run the prediction of 5G in 3.5 gigahertz. Then in one click, so we can import that data into the building, which is in between this macro towers, and we can visualize that, okay, what is the coverage from outdoor to indoor. The first one now I'm showing to without calculating the parameters of the wall partitions. Now in iBwave have another feature. So we run the prediction engine again, then you can see the impact of the macro considering the wall partitions. So this is super important. So you have to take care of the outdoor planning, import that data, then run prediction again, so we can realize that how the macro is affecting indoor and what is the dominance, who is dominating. Indoor is dominating that area or outdoor is dominating. If outdoor is dominating, how much area it is dominating. So iBwave will have a complete result of that. Based on this data, we can optimize the indoor design for 5G. You can see the best server plot and SSRSRP plot. So this is the way, and this is the use case what we did in India, and we would like to share this to all, and our existing customers are all following this workflow model. Outdoor, importing indoor, optimize in indoor, then make the design for 5G. So you will get a very optimistic and design. So this is another use case when we use iBwave reach for a mines. So you all know there are challenges in making a mine design, because to accurate the RF and modeling the RF environment is tough, and also we cannot get a space wherever we want to implement a telecom infrastructure like a pole or tower in the mines. It is very difficult because of the fleet taxi movement and the type of the mine, the geographical challenges of the mines. So, and another is prediction, how to run the prediction in different level of the mines. It is also as a challenge, and there is a reporting and standardization process. So iBwave reach will help our customers to make a predictive 3D modeling of the mines and the design for outdoor with all the frequency bands, not only for 5G, it support LTE, Wi-Fi, IoT, and 5G, then the standardization. So I can show you one result here. So this is a screenshot of iBwave read software, and we create multiple macro sites, and we run the prediction. You can see in the right side the legends. So in this kind of terrains and environment, also iBwave have that capability to make the very optimistic design. So I'm concluding here. So 3D modeling and optimizing the indoor component characteristic, also the geographic area, then the very optimistic prediction. This is the super important thing when we go for a 5G indoor and outdoor campus type of environment designing. So that's it from my side. I know it was very crisp and quick. If anybody interested to get a detailed discussion, kindly connect with us. Thank you.
That was a brilliant presentation, Rajesh. I appreciate that. Thank you so much. Now, moving on to the next speaker, let me introduce Hafiz Muhammad Atullah from Pakistan to present on 5G security. Over to you, Hafiz.
Thank you so much. Let me know, is it my screen is visible or not?
Yes, sir.
Thank you. Hello, everyone. My name is Hafiz Muhammad Atullah, and I'm here to talk about the securing the 5G era. Definitely, firstly, I would like to express my gratitude to the organizers, especially Mr. Ganesh, for this event, for giving me the opportunity to share my thoughts on this important topic. As we all know, the adoption of 5G technology is rapidly increasing across the globe, and with it comes the need for enhanced security measures to, to protect the against potential threats. So in my presentation, I will discussing all the details of the securing the 5G era. So let's get started with my introduction. My name is Hafiz Muhammad Atullah, and I am head of information security at Nanotex and lecturer of computer sciences at Newport University, having more than 15 industrial certifications from Microsoft, Cisco, and other big names. Here is the table of content that I will discuss in today's presentation. And so start with a quick background. the first 5G radio network are live now, definitely. And this generation of telecommunication system aims to deliver the three parameters. One is enhance the mobile broadband, second, massive machine type communication, and third is ultra reliable and low latency communication. Definitely, the purpose is to be faster and more reliable and manage the scale of devices predicted for the mobile Internet of Things and enabling the digital transformation of our society and businesses, process, and manufacturing, definitely. So 5G has designed in security controls to address the many of the threats faced in today's 4G and 3G and 2G networks. And these controls include new mutual authentication capabilities, enhanced identity protection, and additional security mechanisms. But the adoption of new network technology introduced the potential new threats for the industry to manage. Basically, 5G standard development has adopted by the secure by design principles, leading to the three parameters. First is use of mutual authentication, means confirming sender and receiver have an established trust and the end-to-end relationship is secure. And second is presumed open network, removing any assumption of safety from the overlaid products and overlaid process. And third is definitely an acknowledgement that all the links could be tapped. I mean, ensuring the encrypted information is worthless. Although these all are the common practices in solutions for other services, such as online banking and fintech services and so on. So the 5G standards describe a number of implementation models, although there are plans to deploy at least 5 additional options. But we have, firstly, we have 2 models, right? Because only option currently being deployed is so-called non-standalone NSA mode. This is more precisely referred to as ENDC. This is where 5G base stations are integrated with an existing 4G network, working in tandem with LTE base stations and connected to the LTE core. And this is basically relying on the protections that the LTE core provides, right? And second phase of 5G deployment will be likely to be standalone. This is SA mode. This is more precisely SANR, consisting of the 5G new radio networks. And this is basically connected to a 5G core network, I mean 5GC, right? So the change to a 5G core will allow the full security features of 5G specifications to be realized. And although it is recognized that new standards, I mean, cloud native service-based architecture will introduce to new security challenges. Now, the network protection. Basically, 5G introduces a new network architecture element, that is the Security Edge Protection Proxy, SECP, right? The SEP protects the home network edge, acting as the security gateway on the interconnections between the home network and visited network. This is designed to provide the application security, end-to-end authentication, integrity, confidentiality protection, using the signatures, using the encryption of all HTTP2 roaming messages and message filtering and policing, including the cross-layer information, including the and all the addresses information on the IP layer. So basically, but here is the new protocol stack have mainly used the proprietary protocols for network management, and this is an IP-based protocol stack allowing the allowing with a wider network of services and technologies in the future. But some of the protocols and schemas will be adopted in near future that lead to short vulnerability to exploitation, timeline, and higher impact of vulnerability location within these protocols, and the expand the potential pool of attackers. So basically 4G and especially 3G the core networks benefit from attackers having little experience with the proprietary standards used within them. So we have HTTP2 over N32, replacing the diameter of over the basically S6A reference point. And also we have TLS. This is an additional layer of protection providing encryption and communication between all network functions inside a public land mobile networks. And also we have TCP as the network, as the basically transport layer protocol, as replacement of the SCTP. This is again a transport layer protocol. And also we have RESTful framework with Open API 3.0 as the interface definition language IDL. Okay, basically technology that leveraged by 5G is virtualization. And the 5G network architecture will be service-based, meaning that the core network operations may be performed throughout the functions outside the operator network. For example, the cloud, and this is a major shift from established core network security control. And we know it offers the operator the opportunity to leverage virtualization technology. And all the virtualization technologies enable the network segmentation, resources, isolation, ensuring the security and reducing the impact of successful attacks. So the configuration of these services should be basically carried out with a secure by design and to ensure the protection offered is not nullified by poor management and processes. Second is cloud services. This is again, 5G architecture has been designed to be cloud native as it brings to elastically and scalability using the cloud technology and supply chain and liability chain and so on. Also, there is network slicing where each isolation type must be integrated at design phase. For example, a network slice for remote surgery must be considered constant mutual identification and to stop MTIM attacks and threats, but a slice for AR, VR content management will not require the same level of security as we know, right? Also, we have mobile IoT as well as eSIM, as well as artificial intelligence, where we should leverage machine learning and deep learning to automate threats and fraud detection. However, these technologies is also available to the attackers and AI-driven attacks. Basically, experience has shown that 2G and 3G networks make use of insecure and unmanaged protocols and are subject to fraud and threats on the regular basis. So many of these attacks have been mitigated with 4G and 5G. However, due to the backward and due to the compatibility of 4G with 3G and 2G and 1G, they will not disappear until the legacy technology or backward compatibility is created and cheesed. So as shown in this figure, we have three eras. We have three eras in having different three parameters that will have to consider how these legacy network will impact them over the time. Also, we have future 5G security activities and programs. So these are some of the recommended programs and services that are supporting the mobile security ecosystem, including the fraud and security group, future network program, CVD program, IoT security program, and IoT security risk and network groups. So that's it from my side. I hope you found the information valuable and insightful. If you have any question, do comment. I would be happy to answer them now. Thank you for your attention and for being a part of this presentation. Thank you.
Thank you, Hafiz. That was awesome. I appreciate that. Now, let me introduce Mihaela Parfeni from London, UK, to present on 5G gaming, esports, mobile gaming real time. Over to you, Mihaela.
Thank you very much, Kanesh. And again, thank you for getting in touch and providing such a good opportunity to speak on the related 5G topic, such as gaming. So I will soon present my screen, just a sec. So before starting, maybe a quick background regarding my experience. My most experience is based on 5G, 5G NR. In general, what I'm doing is the trials and demos and validations, both on network side and UE side. So we helped many customers in Europe to launch their devices and done a lot of troubleshooting with them, ensuring that the technology is coming to the market as soon as possible. So obviously for today, I choose the mobile world, so the 5G in the mobile industry, the gaming and esports. For those who are part of the telecom industry, it's you probably know this triangle, which showcases the main properties of the 5G. So addresses, the 5G is going to address enhanced mobile broadband, so mean higher data speeds. We are looking at ultra reliable low latency communications and massive IoT, also known as massive machine type communication. And it's really that the gaming and the mobile industry take advantage of 5G in this sense, because we'll have enabled faster transmission, we'll have fewer interruptions, and much better connectivity between sensors and devices in the network. So the 5G ecosystem is really increasing because of the mobile traffic and the video traffic, and we'll see this how it happens very soon in a few slides. But before going further, it's really the question where 5G fits the gaming industry, and there are a few gaming requirements which are a must when it comes to the technology. And obviously, first thing that comes into my mind is latency, quality of service and quality of experience management, and the jitter effect. Well, if you refer, for example, in a video streaming, a TV service, probably the latency that you'll be happy with are going to be a couple of seconds, 4 to 15 seconds. But if you're really referring to the gaming experience in the cloud gaming, this goes to a level of milliseconds. So you'll have around 80 to 100 milliseconds. If you're doing the multiplayer, meaning that you do need even more low latencies, and this is around 10 milliseconds or even less. So it's really the challenge of the technology can be only supported by 5G. Again, looking at the QoS management and quality of experience, there is going to be a challenge for the service providers, because the 4G technologies and the other wireless technology are still going to be here for some time. And for the scenarios such as mobility, it's very important to know how do you manage a seamless experience between those technologies. So there are some challenges that need to be addressed. And then the jitter, it's actually looks at the packet loss and packet delays, well, are addressed by 5G. I said, obviously the 5G is going to, the 5G in gaming is going to change also the way we consume media content and the gaming experience. So we're gonna have immersive, let me just point, we're going to have immersive media experience. So with the help with AR and VR, the cloud computing is really going to help us to get at the experience as never before. So we are gonna have, thanks to the multi-sensor environment and multiple players will be able to access and really feel like, you know, they're going to reach a gaming experience as never before. And thanks to the mobile world, the mobile because nowadays the mobile devices are continue to become an important player in the gaming industry. So we're going to play everywhere, because obviously the mobility that gives us the devices is incredible. We're going to have enhanced gaming with VR and AR. We're going to have enhanced media production. So it is really the technology, the 5G helps us in this area of industry. And how the 5G actually enables low latency application at scale. So firstly, to mention that 5G was actually designed from the low ground up, because it was thinking, when they designed, it was thinking mainly of the high speeds and low latencies. And for example, for 5G and R, we have the scalable numerology, which allows for shorter slot times, especially in millimeter wave and mid-band spectrum, which actually reduce the wait time. We have the fast processing timeline, thanks to techniques such as front-loaded reference signals, that allows us also for the faster grant uplink transmissions and stuff like that. We have a reliable beamforming and tracking, and we have improvement when it comes to the non-line of sight scenarios. And we have the mini slot features for the short data transmission. So there are great fundamentals in 5G to support the applications such as gaming to be able to drive this going further. So more on the business side and more like data side, just to understand how the market trends are going. So the gaming and video industry, it's going at a high speed as never before. In the latest Ericsson report from November 2022, we see that the video nowadays, it's around 70% of the mobile networks, of the mobile network, but this is going to grow to 80% in 2024. So the video gaming is part of the video. So it's going to, we have a video streaming, a high adoption noticed, and there is, when it comes to the 5G and the cloud gaming, it's estimated around 4.5 billion in cloud gaming revenue by next year. So that's a huge opportunity for a lot of stakeholders involved. And also very important to notice about the esports, because esports gained such a momentum in the last few years, and not because, and mainly actually because the esports nowadays don't necessarily anymore require huge hardware, expensive hardware. With cloud computing, cloud gaming, it is possible to use a mobile phone and to have almost the same experience, which actually also here you've seen that in the Asia Pacific video game market, the growth of the mobile it's continued to ramp up as never before, while you look the console, which will think for a non-gamer, that will think that it's going to be the main hardware to choose from. But no, it's really the mobile that is driving the industry of gaming. And if you're looking at China behavior, these things are also reflected, as China being one of the main country which are very much into the gaming and esports, and obviously mobile 5G gaming. So 5G is here to help us with the ramp up of gaming even further. So a small glance of the history of gaming, as you see here, which gives the same information and the same projection worldwide, that we, from around 2010, we have this huge push which is going to grow even more with the 5G. So there is a great area to explore. For the gaming and video market dynamics, what I wanted to show you here is that China, it's really a leader player when it comes to the gaming industry and mobile gaming industry in general. It says that around 72% of the adults in China plays at least once a week. And most of the people in China have a 5G subscription with their 5G gaming subscriptions, indicating basically that there is a high correlation between those two technologies, and that it's adoptions on the user side of the 5G, and they see it only most of likely through the 5G happening. And the Chinese government, and sorry, not the government, but the Chinese companies, they're very much into aligning their strategies, their company strategies with the gaming industry, because it gives a very high revenue when it comes to the earnings. Obviously, there is challenges when it comes to 5G mobile gaming, and as my previous colleagues mentioned, that there is a necessity to build more the infrastructure. It needs to be more the SA, the standalone 5G. It needs to be pushed even further. The cloud gaming, it needs to be pushed at scale. Because obviously the infrastructure is such a costly deployment, so we really need to emphasize on this basically, and then work on technology maturity and invest in the content, as may of gamer developers may not feel very comfortable in actually uploading their source code to the third-party gaming cloud gaming company. But the main idea, what I want to say, and I'm going to finish because I understand my time is going up. So there's a different mindset when it comes to the Asia and Europe, and this is also conceived by the 5G rollouts in China, for example. The growth of the number of base stations, 5G base stations, is so much higher than what happens in Europe. And because they have a very different mindset, Chinese mindset is to deploy the technology and then to find the use cases. But then when it comes to Europe, because there are so many service providers, the idea is to find the best, find the use case, and then move to deploy the technology, which explain why things such as millimeter wave, SA, are maybe slightly more delayed as we would expect it to be. And the general conclusion for all of this is that obviously 5G is here to support the gaming, it's here to support the esports industry. All the trends shows that is their adoption started, the mobile gaming is on fire, and there's only great opportunities to pursue in this direction. Thank you very much. I think that's all my presentation.
Thank you, Milena. You nailed it, particularly when it comes to the China market. I think China is really opening up in terms of the spectrum regulation. One of the very few countries in the world who is opening up the spectrum for anybody, any industries, test it out the private network for free, just to commercialize them. So, they are really going all out. So thank you so much.
Yeah. Well, when it comes to the spectrum, you know how it's in Europe. It's such a regulated environment, and it's so expensive for the service provider to acquire new spectrum, and it's a challenge. It's a challenge in Europe when it comes to this. Thank you.
Yes, thank you. Now, let me introduce Vanitha Ramaswamy from Singapore to present on 5G, edge, and cloud. Over to you, Vanita.
Thank you, Ganesh. Let me share my screen. Okay. Sorry, you're able to see my screen?
Yes.
Right. Hi, everyone. Good evening. I'm Anita. I work as a principal solutions architect at StarHub, a Singapore-based telecommunication service provider. Though 5G presents an enormous opportunity for the enterprise segment, there are some challenges in developing and launching new services. I'm going to share what we are doing to scale the 5G service enablement for enterprise customers. Here are some of the challenges that we see. 5G demands a cloud-native design for network implementation. 5G networks were rolled out based on the solutions available back then, that is a fully integrated vertical stack design from traditional network equipment vendors. This has now become a barrier for enterprise 5G service enablement, as these solutions are cost prohibitive and sometimes the interfaces are closed to develop new services. The market has now matured and we have new options to replace the cost prohibitive network functions with third-party network functions to accelerate the 5G service enablement. To address the cloud-native demands of 5G, hyperscalers also have launched their offering. However, I would think that introduces several additional complexities. The edge ecosystem around the hyperscaler infrastructure services also needs to be built, and I would argue that it also doesn't show a clear path for monetization. However, the progress in terms of the tool set and the development practices we are converging now, so that the network functions and application functions can be managed from the same platform. So in terms of the edge ecosystem development, I would think that MNO have existing customer and partner relationship whom we can leverage to develop new edge solutions to develop an open edge ecosystem. 5G service delivery requires the mobile network to be integrated with IP and cloud technologies. This is where we need cross-domain network automation to deliver these new 5G services. The main caveat here is now we need more skilled labors, which is slightly different from the traditional MNO operations. The edge platforms help to manage the deployment complexity of multi-vendor infrastructure. And lastly, the edge solutions don't work in isolation. If we take a AR, VR application or a digital twin application, it might require to run on edge for the immersive experience or rendering. However, these applications still require integration with the core enterprise systems to get access to enterprise data like CAD/CAM models or the building information models residing in a diverse set of locations. It could be on the public cloud, on-premise, or in the private cloud. This is where the pre-integration of networking with the edge solution sometimes creates friction and overhead during the deployments. We now have new locations where we can run user applications in a telecom network that help us to process data closer to the source. However, the trade-off is cost versus complexity versus business value. This is a complex choice and is dependent on the geography and the network architecture of the MNO. The most common locations where these edge platforms are deployed to run network functions or user applications are the network edge and the enterprise edge or the on-premise edge. Latency reduction as a motivation for edge is not as persuasive as once believed. Now we are starting to see a new set of emerging drivers in terms of improved data security, privacy, reducing and optimizing the transport and compute cost, reduce device cost and complexity, and to reduce vendor lock-in. As the telecommunication networks are modernized and modern applications are developed using microservices-based architecture, these new edge locations simplify the distributed application development. This now helps us to take the best of both worlds. We use cloud where we need scale, and we use edge for near real-time performance. We can now develop systems that are optimized for local operations, that is able to work disconnected from the cloud and still achieve global efficiency with network automation and application deployment automation. So in a way, I would think compute services are becoming like a commodity nowadays. The MNO differentiation is the edge platforms are network aware and cloud integrated, and it has the potential to turn the telecommunication network into application platforms. These are not the traditional edge hosting or the CDN hosting infrastructure offered by the CSPs in the past. The edge market is fragmented, and the infrastructure design also influence and impact the application design. Some of the constraints gets propagated from the edge to cloud, which actually slows down the edge ecosystem development. So it's best to understand the application design patterns to make the right choice. The two predominant patterns that I see with the edge solution offerings, I would classify as a hyperscaler or a single vendor edge versus multi-vendor edge platform. Gartner classifies these two architectural approaches as edge in versus cloud out. In the edge in approach, edge applications are designed and built independently from the public cloud, and they may leverage public cloud for batch analytics, AI, ML model training, where we need scale. It's now taking the advantage of cloud as well as the edge. So in the edge in pattern, the edge application don't use any proprietary or native cloud services or the programming models of the public cloud platform. The cloud out pattern is essentially extending the cloud to the edge. These are single vendor proposition. They bring the same management tools and the security tools to the edge, and a subset of native functional services are extended to the edge. I would think the cloud out architecture may not offer the greatest flexibility when dealing with the massive install base or the brownfield deployments in mature vertical industries like manufacturing or retail. These industry segments can be best addressed with multi-vendor propositions. These are the building blocks of the edge platform, the infrastructure layer, the platform layer, automation, and the assurance tools to provide a single pane of glass for management across multiple domains, that is the cloud and the edge. So now, as you see, the architecture has more or less unified, because now with 5G, operators also started to leverage public cloud for some service deployment like the control plane services. So if we map to the HCNFV architecture, the Kubernetes, which is a container orchestration system for automating application deployment, scaling, and management, it performs the role of virtual infrastructure manager and the virtual network function manager. Kubernetes platform has a way to extend the platform through custom resource definition. KubeVirt seamlessly extends the existing Kubernetes cluster to provide a set of virtualization APIs that can be used to manage virtual machines. And this unifies the management of the VM and container application. So the advantage here is it is technically possible to extend the same design across multiple types of edges. You don't have to have different types of platforms. The hyperscaler proposition, I would consider as an infrastructure accelerator to simplify the management complexity. In the MNO environment, it can add a lot of complexities in terms of learning a lot of new proprietary tools that might not directly translate to new revenue streams. It might help to reduce the OpEx, but in a brownfield environment, we need to have a new team with the right skills to get that operational efficiency. So these multi-vendor edge platform, both these platforms solve the network function lifecycle management and automation. The edge solution ecosystem development is an independent problem to solve with an independent set of stakeholders. This is where I think multi-vendor edge platform support for open tools help us to develop an open edge ecosystem. Public cloud proposition also extensively use open source tools. As you see in all the layer of the edge platform, these are some of the common technology stack or the open source tools that are used in both the offerings. So in terms of DevOps and GitOps tools, I would think it's to be best decided by the development team based on the skill set. And for observability stack, Grafana and Prometheus seem to be the de facto tool for visualization and metrics aggregation. These tools are quite versatile. It was once used for IT operations, now used for telecom network functions monitoring and alerting, even for OT operations in the plant. Even tools like Azure Operator for Nexus, those also use these Grafana tools for these monitoring and alerting purpose. So in terms of application packaging and network function packaging, Helm chart has now unified, has become, these are emerging standards, I would say, de facto standards in terms of adoption. So that help us to reduce the management complexity if we pick the right tools, so the teams can be trained with the right skills that is required to manage, do more things internally. These vendor-supported multi-vendor edge platforms are an emerging substitute to handle the edge-to-cloud management complexity. These edge platforms are general purpose in nature today, able to support the application or network function lifecycle management. Over time, they will evolve to integrate with the telco network services, that is converged network services, to provide multi-access and enable more intelligent application. There are a lot of new initiatives driven by GSMA, like the Kamara Telco API and other edge services. So I would think these edge platforms are a critical enabler to transform the traditional connectivity, telco connectivity infrastructure to a software-defined platform. And MNOs are in the best position to offer the edge to cloud digital infrastructure to accelerate the global edge service deployment. CSPs can now launch new global services to help enterprise customers to optimize the transport and compute cost with integrated connectivity and compute offerings. Thank you for listening. Thanks for the opportunity.
Oh, that was great stuff, Vanita. I'm amazed how much StarHub has to offer. Fantastic. Let's discuss more during the Q&A. Let me introduce Stephanie Char from Paris, France, to present on 5G indoor solutions. Over to you, Stephanie.
Hi, Kanesh. Hi, everybody. Thank you for having me today. I will get you back on the market analysis of 5G. There was a lot of architecture, solutions, use cases, so I'm not going to go back in details through every one of them. I'm sure a lot. I'm sure a lot will be discussed. What I want to do is take you through the market analysis and why we're talking right now about 5G indoor and the need for connectivity. So obviously, we've talked a lot about how the market has evolved, how 5G has entered the market, how we're transitioning to standalone 5G, which was not the case and is still not the general case in a lot of countries. But to support that, to support the traffic, we need to see also that we're gonna quadruple our data, mobile data traffic by the end of the decade. So by 2028 in this case. Why? Because we're talking about a lot of industrial application, a lot of also consumer use case. Whoever makes a TikTok video consume data, produce data. So that goes into that. The 5G expansion, of course, the 5G SIM card, let's say, growing from, let's say, 17% right now to 70% by 2028. So also generating by SIM card a lot of data. And because we have a European focus, maybe I reverse engineer a bit. So I'm working right now as a market analyst on 5G and the evolution of the mobile generations with focus obviously worldwide. But for this paper, we looked at Europe and the European Union particularly. So because 5G also make you rethink the production system when you talk, and I think the next speech will be about industrial 5G. So it's rethinking the production mechanism and how you approach the economy. And that will also is a major topic at the European Union for growth and economic development. What's also interesting is that we've analyzed through a lot of interviews as well as market research that most of the traffic right now is produced indoor. So we're talking exabytes, which for those who are not tech savvy, one exabyte is above 1 million terabyte, which is 1,000 gigabytes. So all in all, it's a lot of data, as you can see. And not only global data traffic will increase, but indoor data traffic will increase. And indoor is not just home or office. We will see if it's consumer or industry, different types of indoors. And of course, you can have Wi-Fi, and you have Wi-Fi, and Wi-Fi systems are evolving as well and becoming more reliable. But as you can see on the graph on the right, the problem with Wi-Fi begins when there are a lot of users on the same line, while 5G remains one user at a time, let's say. So in terms of capacity, you have less your free frequency bands like Wi-Fi. When you're in a train station and you get to the Wi-Fi of the train station with kind of a public Wi-Fi, you see that you're more vulnerable to co-channel interference. So the more user, the less quality you have. And obviously the 5G here can ensure you a better user experience than Wi-Fi. Just before, well, two sessions before, we're talking about 5G and the gaming experience, and that will be easier and more performant on 5G than it will be on Wi-Fi, for example. So what does indoor mean really for the two categories, let's say B2C, so consumer, and B2B? Why do you need 5G indoor really? Because as a consumer, you want to stream higher quality videos. You have your 4K, you have your 8K resolution. You have also 360 degrees videos that are now being transmitted. For example, if you want to watch a basketball match, for example, from a different angle than everybody streaming, you will select your angle, you will need quality, and you will need also flexibility in the network. You can have, we were talking a lot about the metaverse. Okay, maybe not the meta idea of the metaverse, but there is a metaverse out there, how to communicate better and online. And that's also a legacy of the COVID, where everybody was bound to home, and we needed to collaborate together in a space. That can be the space. And cloud gaming, we were just talking about it. For which 5G indoor? So obviously when you're a consumer, it's not only when you're in your own house or at friend's house. It's subway stations, so everything that is public transport within cities. It can be stadiums, and we saw that at the last FIFA World Cup, where you needed, because there's a lot of people in one place, and you needed high quality of mobile data. Airport or train stations, obviously. So whenever you're actually it's indoor waiting for something. It's a lot of that in the consumer use cases. Or shopping malls, for example, you have new, you go to a place, you want to buy something, maybe the color is not in store, you want to check online and everything. So to have a better user experience and more immersive experience, you need 5G indoor. So it's for all those different usage that 5G indoor is needed, and also will be needed the more new application come to the market. On the B2B side, it's all about new production modes. So you need augmented or virtual reality. You need digital twins, for example, to prepare the production plan, to design, and you're not always using that in a small office with a good Wi-Fi, 5G indoor. You need to track and manage the indoor environment of your building. You want to automate and have real-time data to act on a certain production line, for example, track objects, all the robotics, everything that you have. That's the example of the Amazon warehouse, where you have your AGVs going from one pallet to the other to deliver the package. So all of this, you need indoor connectivity, and because you need low latency for rapid response to your order, obviously, and high speed, 5G is an answer where hospital, university campus, factories, convention centers, everywhere that gather a lot of usage of 5G in an indoor area, and also, and the first one being also in factories where you have indoor and outdoor, and you need continuity of data, obviously. The use case, I guess we'll have a lot of them in the next presentation, but please feel free to reach out if you need some ideas of use case. Now, 5G indoor is still a little bit problematic, because obviously the higher the frequency, the poorer the penetration. So let's talk millimeter wave. You need a short distance for it to work. So it's more difficult right now, technically speaking, to go cover indoors than outdoors. Also the buildings, not every building has been built when the technology was available. So sometimes you have like big walls, so it's you cannot penetrate easily, or you have tall buildings. Depending on where your antenna is, you need to reach the highest. And here we're still in Europe, so 10th floor building is kind of the example we took. But go to Asia, look up, it's going to be very, very difficult to get to the top. The topography as well. We were talking about people. So the more people, so busy city centers or urban centers, it's also difficult to penetrate indoor. Also, everything that is non-technical. So, for example, for deployment, you have a lot of administrative burdens. You have this complex approval process that needs time, and for you to be able to deploy indoor. And I'll finish on the challenging business environment. So obviously, when you talk about deployment, you talk about investment. Depending on the return on investment, you'll have your kind of idea if it's a public or private investment that is needed. And obviously, sometimes when return on investment is low, the public has to take over. And depending on the case, it can also delay the penetration. Of course, there are a lot of levers. We talk a lot about them in this free report that please scan the QR code to have access. We talk about the trends, the challenges, what we talked about. And because it's kind of European focused, the levers are European, being public funding or administrative, easing the administrative burden. So please take a look. If you have any question, feel free to reach out in the Q&A or on my LinkedIn. I'm available. Thank you very much.
Oh, great stuff. Thank you, Stephanie. The interesting part was the differences between the B2C and the B2B, right? Because both areas has their own strengths. It's good to discuss during the Q&A. How is the trend? Is it more towards the B2B or the B2C? Thank you so much, Stephanie. Now let's introduce Rabi Royal from Melbourne, Australia, to present on 5G private network. Over to you, Rabi. Rabi, are you there?
I think you're muted.
Would you mind to unmute, Rabi?
Hello.
Yes, Rabi.
Hello. Oh, sorry about that. The second. Can you hear me clearly now?
Yes, sir.
Oh, perfect. Sorry. I believe my presentation is on the screen.
Yes.
Perfect. Thank you, Kanish. I'm delighted to have this opportunity today to share with you an overview of Verizon Business and our work in the realm of 5G networks and edge compute. My name is Robbie. I'm a 5G solutions engineer looking after Verizon's 5G and edge compute solutions in Asia Pacific. My presentation today will begin with an introduction to Verizon Business, providing insights into our capabilities and the wide range of services we offer. Following that, I'll take a closer look at some of our distinguished clients who have experienced firsthand the impact of our solutions. As I said today, my focus will be on 5G and MEC, but it's crucial to recognize that Verizon offers a diverse range of services such as connectivity, cybersecurity, IoT, professional services, unified comms, and edge compute. Now, when it comes to 5G, our extensive public network covers the vast majority of the United States. We utilize millimeter wave, mid-band, and low-band 5G networks to ensure access to our infrastructure, even in the most remote areas of the country. Moreover, our network includes Verizon 5G Edge, which supports our edge compute solutions for businesses nationwide. I'll delve deeper into this topic shortly and some of the solutions we offer with that. In addition to these services, Verizon Business also offers private wireless solutions, including LTE and 5G private networks, as well as private MEC solutions, both within and outside of the United States. And we serve multiple countries across various regions and continue to expand our global footprint. Now, we offer a comprehensive end-to-end solutions, and our ability to deliver these solutions in 5G and Edge is significantly bolstered by the extensive network of labs and innovation hubs. We have, as you can see on the screen, 6 5G labs, 5 in the United States and 1 in the UK, and more than 10 innovation hubs. We've created a robust ecosystem for fostering collaboration, ideation, experimentation. And these facilities serve as sandboxes where partners and clients can develop and test various use cases before implementing them in their operations. So now that we've discussed the foundation of our work, I'd like to shift our focus to the real-life impact of these technologies, which is our clients. One example of Verizon's successful collaborations with clients is our partnership with Associated British Ports. Now, ABP is the leading port operator in the United Kingdom. ABP manages a network of 21 ports. They handle approximately a quarter of the UK's seaborne trade. And by working closely with ABP, we provided the necessary infrastructure through deploying a private 5G network at their site at Port of Southampton. Now, this foundation immediately offered ABP with a reliable, high bandwidth, low latency network. We replaced what could have been more than 200 Wi-Fi access points with 7 5G antennas. So think about the infrastructure, the management, and the deployment cost we avoided. This includes supporting use cases as well, so including those that use, for example, real-time video analytics or computer vision to monitor and ensure the safety of staff at the port facilities. So using computer vision to detect whether personnel are wearing the required safety gear, such as hard hats and reflective vests. This would help prevent accidents and maintain a safe working environment. Additionally, computer vision could be employed for container journey tracking, for example, in order to streamline the logistics process, enhance operational efficiency. And the keyword there is operational efficiency, as it is one of the main benefits of our solutions for clients. These are just few of many use cases you could provide to port operators when it comes to use cases built on top of private 5G networks. Another prime example of our commitment to innovation and collaboration is our partnership with Emory Healthcare through the establishment of a 5G innovation hub. Now, Emory Healthcare is one of the leading healthcare systems in the United States, and we teamed up with Emory Healthcare to explore the potential of 5G and edge compute technologies in transforming healthcare delivery and enhancing patient outcomes. The 5G Innovation Hub at Emory serves as a collaboration environment whereby Emory Healthcare, Verizon, and other partners can develop, test, and refine healthcare solutions that leverage the power of 5G and edge computing. This facility would enable prototyping, assessment of new technology and applications. To mention a few, we could talk about telemedicine, remote patient monitoring, augmented reality and virtual reality, not only for actual surgery applications, but also for training and learning, and also for advanced imaging. All of this happening in a real-world setting. One of our other customers, as well as our partnership with ICE Mobility. So ICE Mobility is a leading supply chain provider specializing in logistics and device lifecycle services. So this demonstrates another powerful application of our 5G edge solutions in the realm of automation, as I mentioned earlier, our 5G edge portfolio. What we see here is quality assurance, automated quality assurance for logistics. The goal was for ICE Mobility to improve its quality assurance process, ensuring the accuracy and efficiency of their operations. So they chose to leverage Verizon's 5G Edge. They were able to deploy a computer vision solution, automating the process for their product packing and shipping operations. Now, this solution uses real-time video analytics. The goal is to monitor and verify that the correct devices, accessories, packaging materials, or items are used during the assembly process, and to minimize the chances of errors and streamline the entire workflow. Now, this also facilitates real-time decision-making and error detection. As a result, you can see on the lower left side, we have some numbers as well as to the significant improvement in the operational efficiency and reduction of the likelihood of costly mistakes and enhanced customer satisfaction. Moving to another client is Verizon's collaboration with the Florida Panthers. Now, if you don't know the Florida Panthers, they're a professional ice hockey team based in Sunrise, Florida. Utilizing our 5G and edge compute solutions, we were able to implement a range of applications and services that not only elevate the fan experience, but also improve the overall efficiency of the venue. Now, these solutions include high-speed connectivity, immersive AR and VR experiences, real-time video analytics for crowd management, and smart IoT applications for optimizing energy usage and facility management. For instance, the high-speed connectivity offered by our 5G network allows fans to enjoy uninterrupted live streaming, instant replays, and multi-angle views of the game on their mobile devices. In addition to that, the integration of AR and VR technologies creates immersive experiences for fans, such as interactive games and virtual meet and greets with players. Moving forward, I want to talk a little bit about some of the 5G edge solutions as well. And this is extending from my previous slide when it comes to venues. Verizon's 5G edge accelerated physical access solution. This is another approach to enhancing security and streamlining access control in various settings. It's not limited to venues. You think about this for office buildings and stadiums as well. Now, this uses 5G's low latency and high bandwidth to support biometric identification methods, mainly facial recognition in this case. We authenticate individuals more accurately and quickly. This allows us to process, and the edge compute, capability allows us to process the data closer to the source. Moving forward from there, cashierless checkout solution is another example of our 5G solutions, specifically for retail. The goal here is to streamline the shopping experience and improve operational efficiency for both customers and retailers. Now, cashierless checkout using technologies such as computer vision, IoT sensors, and machine learning algorithms, we automatically detect and track items that the customer pick up from the shelves. And as the customers move through the store and select products, the system keeps tracks of their selections and automatically calculates the total cost and invoices them as they leave. Aware of time, I'll go very quickly through this as well as the last but not least is our 5G deployment at Deloitte's Smart Factory at Wichita. Here we aim to demonstrate the potential of advanced connectivity solutions in manufacturing. This is where Deloitte will showcase the latest advancements in smart manufacturing and provides a collaborative environment for exploring Industry 4.0 technologies for partners as well. Now, the work done at Wichita provides valuable insights for manufacturers looking to modernize their operations, and I encourage you all to look at that. In conclusion, our 5G and edge solutions have been instrumental in driving innovation across various industries. We look at many industries, including logistics, healthcare, retail, manufacturing, and through our collaboration with clients and partners, we are able to demonstrate the potential for end-to-end managed solutions to transform operations and unlock new opportunities for growth. Thank you for your attention, and please feel free to reach out to me on LinkedIn if you have any questions or inquiries. And with that, I'll hand it over back to Kanish. Kanish, thank you.
Great stuff, Rabi. Thank you so much. You have huge varieties of offerings. Thank you so much. Now, to the last speaker, I would like to introduce Anuradha Udunuvara from Colombo, Sri Lanka, to present on the topic, the journey to telco cloud. Over to you, Anu.
Thanks, Kanish. I hope you can see my slides.
Yes, sir.
All right. So I'm talking about a bit of telco cloud and the relation of that to 5G, the topic that we discussed. So I have titled it as Journey to the Telco Cloud. And I think before we start, although we know these terms and the words that we use in this context of 5G and telco cloud, I think it's very appropriate that at least we refresh ourselves and just make sure that we refer to the right thing when we use these things. Now, first is cloud computing, which is a verb and a use case, which actually refers to accessing or rather access to a shared pool of configurable computing resources, and it is defined by NIST with their definition. And if you take the cloud, it is actually the noun, and it is the infrastructure that we refer to, and which is also defined by NIST, and they identify like 5 characteristics, 4 deployment models, and 3 service types, which are very much familiar to us. And if you take the word cloud native, it is more about the applications where we run scalable applications, and we have these familiar words like containers, service meshes, microservices, immutable infrastructure, declarative APIs, etc. And cloud native applications are sort of loosely coupled, resilient and manageable, and also observable. And this definition is from CNCF, or Cloud Native Computing Foundation. But if you really want to summarize what cloud native is, it's basically taking the full advantage of the unique capabilities of the cloud. And if you really look at what the industry or what the ecosystem referred to as telco cloud, unfortunately, we really don't have a universal definition for telco cloud. We have different, although I would not use the word definitions, but different ways of identifying the term telco cloud. For example, VMware identifies it as an NGN architecture that combines more of the softwareization technologies like SDN, NFV, and cloud. Red Hat also used the word software defined and also the cloud infrastructure. Ubuntu uses, or rather comes from the perspective of the workloads and says cloud environment optimized for telco workloads. So we have to have some sort of understanding based on these inputs and the other inputs that we have about telco cloud. I think it's more easy for us to sort of do a comparison between something we already know, which is the cloud, or the cloud which is more specific to IT and enterprise environments, and compare that with the expectations of the telco cloud. And if you take the definition, telco cloud is more, we are referring to a more of a private cloud implementation within telco environments, whereas the IT or the enterprise cloud could be both private and public. Use cases are quite different. I think some of the earlier speakers also mentioned some of the use cases of the telco cloud, which includes, for example, in the context of 5G, 5G core applications, etc. And they are also related to, for example, if you take the latency, very stringent latency requirements, especially because of the telco grade applications, and then high throughput requirements, especially to cater 5G and future 6G requirements, and more or less dedicated CPU allocations because of the performance requirements, and high availability, high resiliency requirements, reliability requirements. And if you really look at the distribution, I think, again, some of the speakers earlier mentioned with the edge, now cloud could be anywhere. So we could have very much a distributed data center or the cloud implementation. And the standards, again, some of the standards, most of the standards that we use in telco cloud come from open standard initiatives. But if you really want to look at, because given a telco environment, we have both IT enterprise workloads and the telco workloads, because within any enterprise, any organization, we have the IT enterprise part. So either as a telco, you could have your IT cloud separately, telco cloud separately, or you could have a common cloud for both IT and telco workloads. In terms of mapping this to a journey, starting from the traditional implementation of hosting different telco solutions, services, and applications towards what we mostly use today in the world of cloud native, you can see if you really map it with the generations of mobile technologies from 3G to 4G to 5G non-standalone, and then finally 5G standalone, you can see we are moving from a traditional dedicated, more static implementation of telco applications on dedicated hardware to with 4G virtualized environments, and then bringing in automation and orchestration with non-standalone 5G, and going forward having full digital experience with cloud native applications. And if you really look at the space of standards, we are moving 3GPP. Of course, all the mobile standards are defined by 3GPP, but Other than that, we are bringing in other standards like open cloud management, like OpenStack, then bringing in automation with Ansible, maybe HC, NFV, Mano type of environments to manage and orchestrate the cloud environment. And in this generation and in the future, we will be more using microservices architectures with the tools like Kubernetes and several other cloud native technologies to bring about the real capabilities and the opportunities with the telco cloud-based implementation of 5G standalone and non-standalone implementation. So 5G is basically end-to-end IP, and also it uses a lot of cloud-native technologies. Now, if you really look at the change of the different business models that we have in the ecosystem, especially coming from the vendors and our partners, we see that the industry is going on a change from more or less the closed hardware implementations of different capabilities to in today's open APIs. That is the industry's overall change, and how our suppliers, vendors, and partners actually making themselves to this change is basically, if you take the traditional, the tier one incumbent vendors, they try to use more or less start with closed source implementations and then make it open source and then try to bring in telco cloud capabilities. And we have another set of vendors who are not the tier ones, but the tier twos and tier three, the industry challengers or the disruptors. They try to bring in, or rather bring cloud native technologies very much early in their product portfolios, and they very much start with open mindsets, with open hardware and open software. And also we have the cloud players or the hyperscalers who are very much were focusing on public cloud infrastructure and public cloud offerings, now try to introduce telco cloud capabilities. So we again have this debate of where do you really run your workloads? Is it towards the edge or towards the public cloud or in the middle? So these cloud players could have offerings to implement certain things on private environments, but certain things in the public environment as well. So going forward, I think we need to understand that as telcos, we have different starting points in that journey. One could be in the very early stages, one could be in the middle stage, or one could be in the very final stage of like 100% cloud native type of environment. But these journeys are quite unique, and we need not and should not map somebody else's path, somebody else's journey to try and use our cloud native journey. And as one of the speakers and few of the speakers mentioned, bridging the skills, knowledge, and education gap is going to be one of the key areas that the industry need to focus, especially the telcos. And you need to have your short, long, and midterm plans. And it's very important that you partner with the right partners. And these right partners may not be your incumbent partners or incumbent vendors or the suppliers, OEMs. So you need to evaluate the capabilities of them and also the newcomers. And the importance of doing your internal research and development and getting your hands dirty is also very important, especially given that most of these implementations are based on open source technologies. For example, China Telecom, they have their own OpenStack cloud platform listed in OpenStack. So similarly, telcos can have, and I think they should be doing more collaborative work with open source communities and open source projects. At the same time, you also need to be mindful I want to leave you with these 2 points from the Linux Foundation and Gartner, that by 2025, 75% of data being generated globally by edge computing. And from Gartner, it says 50% of enterprise managed data will be created outside of data centers and outside of cloud computing environment. So going forward, I think we need to really relook at what the cloud is, and in that sense, what the telco cloud is. Going forward, I guess the cloud could be anywhere, and we need to adjust ourselves and be mindful as we move forward in that cloud telco cloud journey. So that's it from my side. Thank you very much.
That was awesome, Anu. Excellent, nice conclusion. Thank you so much, Anu. Really appreciate that. Let's have like 10 minutes Q&A session among all the speakers. You know, every time that I conduct the Q&A, it's very boring stuff that I'm the one who have the question. So I think to open up the floor, maybe any of the speakers, you have any clarification or question from any other speaker's presentation, I will open up to anyone who have any questions. Please feel free so. If not, then maybe I'll take the lead. I have just one question as what I mentioned earlier regarding about the 5G indoor challenges. I think this is quite a critical moment where it's a global phenomena issue where a lot of smart city developers or indoor solution or indoor customers, hotspot areas are complaining about the experience of 5G coverage in the indoor. So the question is, what is the main issue? Is it the frequency spectrum, or it can be the approvals from the city developers or the building owners, or is there any other technical issues that it can be an issue, right? So as we know, the most popular spectrum is the 3.5 gig spectrum, right? Some recommends the 600 to 900 megahertz. Unfortunately, there's limited use cases, but it can give a very good coverage of penetration within the indoor. So all the other area to look into is the millimeter wave, which carries much more better indoor solutions, but there are limited use cases with the indoor. There's a pro and there's a con. So I'm leaving to the floor, whoever have some better experience from their customers or from any of their counterparts, anyone who would like to take this up.
Hi, Ganesh. If that's fine, I will share my point of view, but this is more related not necessarily to areas like malls and, you know, public spaces, but I want to emphasize on the fact that with 5G, the private network is going to kick on. So there is no solution that fits all, obviously, and really depends on the use cases and, you know, what's the company's needs at the end of the day. So I believe that the private network is one of the areas that is going to boom in the next few years. There's going to be a lot of players. What is very good about the private networks is that we're going to have a lot of compatibility between different players. There's going to be, I think many companies already started to, as Qualcomm started to work on the so-called 5G blueprints. So it's because obviously we need to, when offering a private network to, for example, to a customer, we need to take off the complexity of this private network that is going to be very easy to manage. at the customer side. So this 5G blueprints is going to give some package of different compatibility, different players, different devices. So everything is going to be installed there. So then it's going to fill the needs of the customer in terms of bandwidth, in terms of the coverage, in terms of the security, which is a very big point nowadays on the 5G, cybersecurity. So that's one of the areas when it comes to what I see the indoors needs. So it's going to be covered by. Another thing to mention, I think a big topic nowadays in 5G, it represents this network slicing. So really providing the going basically to have virtual networks, and on these so-called virtual networks, we're going to give the customer the quality of service that they're looking for. That's another thing that can be addressed in terms of customer needs with 5G.
Thank you, Miela.
Thank you. And
If I
yeah,
can add, sorry, go ahead.
Sorry, Stephanie, just a short point to make is that, I think initially in the early days, I believe that there was, at least in Europe, more expectation that millimeter wave will kick off. And it has quite a hard time, I believe, in Europe to do so, which is actually a shame because developing a millimeter wave in indoors in a concentrated area, it's a very good solution. So, well, you can argue because also Wi-Fi is very good, and it's a kind of a competitor, Wi-Fi 7 to the millimeter wave. But I think that there are some solutions to be in 5G, important solution to be considered. Thank you.
If I can add on that and to come back to your question, Kanesh, I think there are technical and non-technical barriers. So to explain very broadly, the lower the frequency band, the further you can go. Obviously, here we all know that. But the problem with 5G is that you get to higher bands, so the distance is way smaller, and so that's where the technicity comes in. You need more antennas, so you need more relays to get indoor. Mostly when you have buildings that were not built for the purpose. Obviously, when you have to consumer-wise, if you want to put 5G indoor in a very old museum or in a medieval castle, it's not built like we build buildings now, where you have maybe more spaces where the wave can go through. So you need to rethink technically how to bring 5G indoor, not from an outdoor perspective going indoor, but really indoor built. And that's how they do the private 5G that Mihaela was talking about, and everything that is smart factory. It's really built for indoor purposes. That is another investment that when you are on a public network, like for service providers, they have one investment to cover countrywide or whatever their targets are. But that's a lot of money. So that's also the investment part that you need to act on if you need to equip, as I was saying earlier, a stadium, for example, for consumer purposes. We have the Olympics in Paris in 2024, so that's a lot of experience in that. And it's another investment if you're a private company or industry putting your indoor 5G system. So there is the need technically for more antennas to rethink how you build your network, but there is also the financial aspect that is very important, and obviously how to build buildings according to the wavelength and support wave penetration indoor.
Fantastic. Anyone wants to add anything?
Let me add a few points here, Kanish. I think as Stephanie also mentioned, irrespective of the generation in wireless communication, we have these characteristics where if the frequency is higher, your distance is low, and at the same time, if you go to higher frequencies, your penetration is also difficult. And if you take the 5G context, as previously some of the speakers mentioned, the most lucrative type of services on 5G today is the entertainment side, and video plays a huge role. And other studies also show that most of the consumers, although we talk about mobile technologies, the 5G and 6G services, and to a certain extent 4G services, are actually consumed in-house, inside buildings, right? So we have all these parameters in our design consideration: the distance, the penetrations, the frequencies, the usage, which is video, which requires high bandwidth, and also different other techniques as well. So I think we have two main business segments as an operator. We have residentials, and then we have enterprises and corporates. For enterprises, corporates, factories, manufacturing facilities, I think private 5G makes sense. But for in-house 5G penetration, I think we have to combine our efforts with the fixed line network and the mobile network. Things like the picocells, the femtop cells in the 5G world, I think if we can sort of inbuild these capabilities onto let's say fiber, passive fiber infrastructure, something like ONT, ONU, which goes inside the building, rather than having multiple boxes to deliver 5G capabilities. Wi-Fi certainly has certain capabilities and also certain limitations. For example, we talk about 5G network slicing, and the slice could be extended not within the network, but it could be extended up to the device level today. So when you talk about 5G network slice being extended up to the device level, I think we have certain issues using Wi-Fi in your last few feet. So if you really want to extend end-to-end true 5G services, I think for small limited areas, femto and picocells is the solution. And for larger facilities, I guess I agree that we can go with private 5G.
I have a question here. When we look into the as you said, the technologies, right? The femto cells, small cells, and then we have the private 5G. In terms of the service provider, do you think that the mobile operator takes the full responsibility to deploy for the 5G indoor solutions, or do you think the tower cost takes a full responsibilities, or it really depends case to case on different respective countries? How this whole thing works? Or do you think the building owner have 100% responsibility to own the indoor solutions?
If I can start, sorry. The 5G deployment is really different if you go public or private, because public, you rely on some frequencies given by the regulator. In different countries, it has different regulation. Let's take two countries that are side to side, France and Germany. France, the service provider got most of the frequencies. The industrials can have trials for now. It's not officially sold to them. In Germany, it's been sold in the last auction to industrial companies. So they own the frequency, to deploy their own network inside their industrial plant or factory or wherever they want. Now, you were talking about towerco and service provider. Again, 5G deployment is on different, has a value chain. So you have obviously the passive infrastructure where a towerco can compete with a service provider to deploy the towers and antennas, but they cannot deliver the active service. So that's only the service provider at the public level. What they can end, because service provider can be also clients of towerco, obviously they're not going to hijack their own business model and compete with their own clients. When you're private, however, you don't have the same rules. So the service provider is not the client of the towerco on the industrial plant, so they can go with the ecosystem. Obviously they can build part of the solution, and a lot of industrial don't rely on public service provider. They have their own ecosystem of equipment vendors, of smaller 5G providers, of tower companies. So the ecosystem is very different, and usually for large plants, obviously you need a larger ecosystem to provide solution end to end. But yeah, so those are two very different business model, and you don't have the same actors in both.
Hi. Yeah, just I agree with Stephanie, and just as a small point to make. In the private network, 5G private networks, we'll see the system integrator players, which what they're going to do is actually they're going to work with all the infra vendors. They're going to work with OEMs. So then at the end of the day, they will provide the solution for the private consumers, for the enterprises. So it's actually their job to do that. So I believe like companies like Capgemini, which are positioning themselves as a 5G private network, so they're going to be leaders in doing so. And they work obviously with many companies like Microsoft on the core side, Qualcomm on the small cells and OEM side. So there's a lot. Is not what I've seen. What the trends are showing that is very different than what used to be before. Is that there's not one play, only one who plays a role. So there is like a teamwork in 5G network. So like everyone works towards the success of the entire solution.
I think there's another point also, because of the huge data and also the complexity of the use cases for the indoor solutions. There's a lot of processing is needed, and you not necessarily need to take or carry the whole traffic towards the mobile operators exchanges. That's where the edge plays a key role, and the edge can also takes a lead in terms of processing within the in-house, so where hyperscalers are providing such a solutions, combination of the edge storage together with the private network, or even the mobile network service provider also are providing such of edge solutions for the indoor solutions, for the storage and speed processing, just to give the optimum quality of performance for those use cases in building solutions. So there's, as you said, you are right, there's a lot of different plug and play combinations are available, and it's really depend whether what is the real relevant use cases that is so important for the indoor solutions, right? Because today there's a lot of complaints coming on in Malaysia, particularly from the smart city developers. They find it that their customers are still not able to enjoy, especially the end users. They couldn't able to enjoy such use cases, even though they are subscribed to the national mobile network. So they enjoy very well during the outdoor coverage, but when it comes to indoor, there's a lot of complaints from the end users. So I think it's a wave, like what happened from 3G towards to 4G, and now from 4G towards to 5G. There's a lot of problems will still arise, but I think over the time, there's a lot of learnings are needed by all the stakeholders, and everyone has got to help each other to see what is the best solution. And it will take a couple of years to get stabilized.
Yeah,
And don't
one more
forget,
point.
it's a tools. Sorry, go
Stephanie?
ahead.
Oh, all right. I guess I just want to add one more point on that, since we already talked about private networks for a little bit. One other use case that we had, since the user experience is the most important here, is extending the public network with all of its capabilities and bandwidth to indoors. One example we had was working with WeWork in the United States, where they wanted the power of our millimeter wave 5G connectivity indoors for their clients. And we made a deal to provide them with Corning cell sites indoors to extend the network to all areas within their facilities. So at the end of the day, it does depend on the use case that the client want to have, whether the public network is good enough through extending it with a Corning indoor cell solution or a fixed wireless access solution, or at the end of the day, they might need a private 5G network that is maybe air gap to their own employees and staff.
Good one, Ravi.
And I just want to highlight and strengthen the fact, because we're all kind of professional in 5G here, but maybe people tend to lose themselves in the technicity of it and forget it's a tools to an end. So it's what when we say it depends on what do you need and how 5G will get you there. It's not let's put 5G and then see what we can do, because obviously time, money management, you cannot build a business case on that. So go back to, and mostly on private 5G, which type of network you want to use, depending on what you need. Do you need a public network? Do you need a hybrid network? Do you need a private network? Who are you bringing around the table? Do you just need the network because you know how to do everything? Do you need people to manage it for you? So that's why go back to the business case, what you want to achieve, and 5G will be the answer how to get to there.
Oh, yes.
Please.
Totally agree, Stephanie. Yes. For example, if you're referring to the private network, especially the use cases that are very machine critical and where the latency plays a big role, then yes, obviously the private network is going to be the answer to that. And because I think we tend less in today's call to discuss on the security side. Obviously, there has been great points made. However, we need to emphasize that there is big concerns when with the data on the security front, and you really want, as an enterprise or as a critical business, to have your own network. You don't want your data to be hacked, and so for the business cases that it's very critical for the business, then yes, private network is the solution.
I tend to see that in Europe, particularly in UK, France, Germany, Italy, so on and so forth, there's a lot of opening in terms of the private 5G network offerings, US mainly as well. And this gives a lot of leverage for new vendors. There's more than 200 smaller players are able to give some sort of a food on their plate to open up the business. But unfortunately, the major part of the Asia Pacific are still dominated by the big boys, the big boys vendors. And these are the people who are backed by the big mobile associations and all this. And this, it looks like very much towards a monopoly game by the big boys, mobile operators, right? So this is another challenge that the private 5G is still not really getting that grip in this region, Asia Pacific. China is exceptional because they have opened up the spectrum, the regulation, and there's more players can come in for free, right? There's no cost for the spectrum for private 5G. But not all the countries in Asia Pacific are following, are practicing that. So there's a lot of influence involved by the big boys back here, right? So yeah, I think it's an issue. I think Asia Pacific should emulate the European and the US in order to give an opportunity for other players to grow the ecosystem. That will be much more healthier. Anyone wants to add anything? If not, I really thank you so much for the speakers. Thank you for your time. I really appreciate for your contribution. And this video will be uploaded on YouTube in another couple of hours. This will be very useful to a lot of stakeholders, to our audience, and also whoever views from our LinkedIn profile. So to all the audience, please take a couple of seconds to click subscribe on our YouTube channel, Global 5G Evolution. It will be truly beneficial to everyone. The speakers can be contacted if you require any support or services, or you want to purchase any of the offerings. Thank you so much. And till we meet again, have a nice day, have a great week, and hasta vista. Thank you so much.
Thank you.
Thank you. Have a good day.
Thank you very
Thank
much.
you, everyone.
Bye-bye.
It was a
Bye-bye.
pleasure. Thanks.
Thank you.
Thanks.
Bye. See you.